Right, guys. So today we're learning how to create and solve equations. And our central question today is, how do you use an equation to model and solve real world problems? So if you guys remember on 2.1, that was the last notes video you're supposed to watch, we were learning how to create expressions given a real world situation. Well, now we're just creating equations. And the only difference between an expression and an equation is that an equation has an answer. So equation is always going to have the equal sign after it. So really, we're just adding an equal sign to whatever it is we're trying to describe. Now, when we're doing these type of problems, it's important that we do a couple things. So first, identify the important information. So we're going to use our reading skills. Step 2 is going to create a verbal description. That just means we're just saying verbally what it is that we're trying to do. And then finally, translate that description into an equation, and then we solve. So let's look at our first example. We got Roman and Enrique, and they're going to go bowling. Roman's score is twice the difference between Enrique's score and 20, and the sum of their scores is 320. What are Roman and Enrique's individual scores? So what I like to do first is just highlight important information. So what could be important is that Roman's score is twice, which means it's 2 times the difference. And difference is subtraction. So it's the difference between Enrique's score and 20, which means whatever Enrique's score, take away 20 is, that's Roman, 2 times that is Roman's score. And then I also know that the sum of their scores, it's not gonna work. The sum of their scores is 320, which means if I add the 2 scores together, I'm going to get 320. Look, I gave you the definition there. And then finally, what we're trying to figure out is what are their individual scores. There we go. So, verbal description. Well, I know Roman's score. I'm basically almost going to copy it word for word. But Roman's score is the same as 2 times Enrique's score minus 20. And the reason why I'm writing it out like that is because the way this problem is worded, it's not that straightforward. And so by writing it out like this, it's going to be easier for me to create the correct expression for Roman's score. And then I also know that Roman's score plus Enrique's score equals 320. So those are my 2 things that I know. So now what I'm going to do is just kind of write an equation. Well, since Roman's score is the same as 2 times Enrique's score minus 20, I'm just over here going to try to write an expression just for Roman's score. So Roman's score is going to be, it's the same as 2 times, remember parentheses means times, Enrique, which is E, minus 20. So this says in math exactly what we wrote here. Roman's score is the same. So we can even put equal sign equals 2E. So 2 times Enrique's score minus 20. And the reason why the E minus 20 is in parentheses is because that is going to give me a number, right? If I did 2E, just 2E without the parentheses, then it'd be just 2 times Enrique's score minus 20. But this is Enrique's score minus 20 times 2. So that's why we're doing it this way. So now that I have Roman's score, Enrique's score is obviously just E. So I can write my final equation that I need to solve, which is going to be, so if I put this guy over here, I'm going to have 2 parentheses E minus 20 parentheses plus Enrique's score, which is just E, is equal to 320. And now I'm going to solve the equation. So I'm going to start with multiplying the 2 in and using my distributive property or math rainbows. So 2 goes to E, 2 goes to negative 20. 2 times E is going to give me 2E. And 2 times negative 20 is negative 40 plus E equals 320. All right. Now I'm going to combine my like terms, which is the 2E and the E. This guy's right here. And 2e plus 1e is 3e. I want that pink color. I don't like that color. What the heck do we got? Well, it's purple. So then I'm going to have 3e minus 40 equals 320. Oh, that's 33. 3e. All right, and then now I'm just going to solve. So I'm going to start by adding. Ooh, that's gross. Don't do that. Why isn't there like a pink? Okay, there we go. This one back to purple. All right, add 40 to both sides. And pink. Can't one of these guys. And then add 40 over here. So remember, the reason why I'm adding 40 to these, because if I add 40 to negative 40, I get 0, so it cancels out. And then now I'm going to add 40 to 320. So this guy's gone. And I'm left with 3e is equal to 320 plus 40, which is 360. I divide by 3. Why would I have gray? That's such a terrible color. All right, divide by 3. Doing that, that's going to give me, oh, what happened? So first of all, it's going to cancel the 3 on the left. And then on the right, 360 divided by 3 is going to give me, oh my Lord, is going to give me 120. So E is equal to 120. So that's Enrique's score. So we know Enrique's score is 120. But remember, we want to find both of their scores. So I know that Enrique plus Roman is 120. Or sorry, it's 320. So remember, Roman plus Enrique is 320. This guy over here. Well, Enrique is 120. So then Roman has to equal 200. Because 320 minus 120 is 200. So then finally, rest of my answer, Enrique's score is 120, and Roman's score is 200. All right, so one thing that you can do is I want you to answer this on your own, is what might it mean if a check reveals that the answer to the real world problem doesn't make sense? So what happens, what would, like in this case, what would that mean if Enrique's score was actually 400? So this is where you really need to kind of use your critical thinking skills. So going back, if both of their equations, their scores added together is 320, then Enrique having a score of 400 isn't possible, which means that you probably did something wrong. So that's where you're going to want to go back and check it. So always just make sure that you're doing it correctly, and just make sure your answers are reasonable. So finally, last question. This is when we have variables on both sides, and just fair warning, the rest of this unit is pretty word problem heavy, which I know you're not a fan of, but what I like about it is that all of the word problems are going to be set up the same. So once it's like you get used to the pattern, it becomes a lot easier to solve. So in this problem, Maggie has offers at 2 companies. One company offers a starting salary of $28,000 with a raise of $3,000 each year, and the other company offers a starting salary of $36,000 with a raise of $2,000 each year. In how many years would Maggie's salary be the same at both companies, and what will the salary be? So again, I'm going to go back, not highlight everything, but highlight the important information. So this time we're talking about 2 different companies. So what I want to do is just kind of identify those 2 different companies. So one company, company 1, has a starting salary of $28,000 with a raise of $3,000 each year, which means each year they're getting another $3,000. And then company 2 has a starting salary of $36,000 with a raise of $2,000 each year. What we want to know is how many years are they the same? And what is the salary? That's what we want to find out. So what I want to do is I'm going to come up with an expression for company 1. And again, we're going to start with a verbal expression. So company 1 starts with 28,000 and adds 3,000 per year. Company 2 starts with 36,000, so a lot more, and adds 2,000 per year. What we want to know is when does company 1 equal company 2? So whenever you want to find out if there's two things are the same or when they're the same, you set them equal to each other, and that's going to tell you when they're the same. So let's start with writing. I'm going to actually move this guy over here. Move this down here. So I'm going to start with writing my equation for company 1. So I'm basically going to take this and put numbers in it. So I know I'm starting with 28,000 and I'm adding 3,000 per year. And so since I'm adding per year, I'm going to slap an X. If anything is reoccurring, it's going to have a variable there. I could have chosen Y, I could have chosen M, doesn't matter. I just chose X because that's something we're comfortable with. And I'm going to do the same thing with company 2. So company 2 does the same thing. It's going to start with 36,000 and then add 2,000 per year. And then again, 2,000x. So now I want to find out when these two guys are equal to each other. So I'm going to set company 1 equal to company 2. So 28,000 plus 3,000x equals, and on the other end, I'm going to put what I came up with company 2, 36,000 plus 2,000x. Okay, so I have variables on both sides, but it's not too crazy. I just want to solve. And so how I solve is I solve by trying to get my variables on the same side. So I'm going to start with subtracting this 2,000x over. And the reason why I'm subtracting the 2,000 is because it's smaller than 3,000. Subtract 2,000x. Subtract 2,000x. Right, so my 2,000x cancels. 28,000 drops down, so it's 36,000. Those are both going to drop down. So what I'm going to have now is 28,000 plus 1,000x equals 36,000. This is just a two-step equation. So now I'm going to subtract the 28,000 over so I can have my numbers on the same side. That's all I want to do. So minus 28,000. And over here, I'm also going to minus 20,000. So then what happens again is this cancels. My 1,000x is going to drop down. So now I have 1,000x is equal to 36,000 minus 28,000, which is 8,000. And I'm in my last step. I just got to divide by 1,000. And I get x is equal to 8. What this x represents is how many years are they going to be the same. So I have half of my answer in 8 years. It will be the same. But now I need to figure out how much it will be. Well, since in 8 years they're going to be the same, that means if I plug in 8 to company 1's equation or 8 into company 2's equation, I'm going to get the same thing. So just for sake of time, I'm going to just plug it into the second equation. So I'm going to have 36,000 plus 2,000 times 8. And actually, you know what? Let's plug it into the second equation too, just so you can see that they are the same. So 28,000 plus 3,000 times 8. So all I did was replace the x in both of these equations with 8. And now I'm going to show you that they are the same, which means that we did our answer correctly. So if I break down this guy, I get 36,000 plus 16,000. And that's going to be 52,000. I don't know if you tried it, but let's check the other guy. Let's see what we get here. So then here, if I do the same thing, we get 28,000 plus 3,000 times 8 is 24,000. And sure enough, add those two numbers together, you get 52,000. So we did this correctly, and we know that in 8 years, both companies are going to offer 52,000. About this time. For Maggie, $52,000. And that is how we do it.